Okay, so it's a good idea to draw a rough sketch of the region in this case. So here we have the parabola y equals x squared. We all know what that looks like. And y equals x squared looks something like that. We're actually only interested in the region that's bounded by these three graphs. So y equals 0 is our x-axis, and x equal 2 is a vertical line, looks something like this. So the region that would be bounded by y equals x squared, y equals 0, and x equal 2 would be this thing that looks a little bit like a triangle, and this is the region that we're talking about in here. Now what we need to do in order to use the disk method, we're going to rotate about the x-axis. So we're going to be rotating this somewhat triangular shaped region around the x-axis. So using the disk method, we're going to make a representative rectangle in our region that is perpendicular to the axis about which we will rotate. So this is our representative rectangle. Now what I want you to imagine is every possible representative rectangle that we could rotate around will form a disk. That's why this is called the disk method. So the area of those disks, if we do an infinite sum of the area of all such disks that can be formed by all of the representative rectangles, all rectangles that could be formed in our little region here, when we add them all together, the areas will add up to the volume that's generated by rotating this graph around the x-axis. So, or the region around the x-axis. So the area of our disk, that's the same as the area of a circle, and that is pi r squared. So the disk method here, the volume will be pi times the integral, because the integral is our infinite sum from x equals 0 to x equal 2, because realize that when y is 0 here, x is also 0. This is the point 0, 0. This is the point 2, 0. So the x value across here of our representative rectangles goes from x equals 0 to x equal 2. And the radius is the height of that rectangle. So when we do pi times the radius squared, our radius is x squared. So x squared squared, which is of course x to the fourth. So our integrand, as we simplify this, would be x to the fourth, and antiderivative would be 1/5 x to the fifth, and then we're evaluating that from 0 to 2, and if you do the arithmetic there, you should get 32 pi over 5. So 32 pi over 5 cubic units would be the volume of the solid of revolution that would be generated by revolving this region about the x-axis.